This video will help you with your one-dimensional kinematics assignment due this week. So on the assignment sheet, I've given you a list of the steps that you should follow while calculating any kinematic quantity. And I'll give you an example here and we'll go through the list. Okay, so step number one is to read the problem carefully. So we read the problem, this football player running to the left, tackled, rebounds, traveling to the right, and the time he's in contact with whoever's tackling him is 600 milliseconds. Okay, let's draw a picture. So we have this football player and he's traveling left. That means his initial velocity. And then there's some big guy here who's going to tackle him and turn him around so that he's traveling now to the right after he gets tackled. Okay, so there's our picture. Next is to write down the variables that are given. Now you will always be given 3 numbers. So you have to be able to find the 3 numbers and identify the variables they go with. So given, read the question carefully, and it says football player running at 9 meters to the second to the left. That's VI, and because it's left, you have to put the negative. Okay, that's vitally important. So that negative means it's going left. Any velocity left is negative, velocity right is positive, velocity up is positive, velocity down is negative. But here it's going left and right. Okay, rebounds traveling to the right, so the final velocity would be plus 8.5. Don't forget the units when you write these numbers down. And then it says this collision lasts 600 milliseconds. So that's T, 600 milliseconds. Okay, that's the next step. Next step is to write down the unknown. So that's the given. The unknown that we're trying to find is acceleration, A, acceleration. Okay, now we're doing what we did on the worksheet. You've got these 4 variables. One is missing. The missing variable is delta x. So we go to the list of 4 equations, which is given on this assignment as well. And you see that the equation you want that's missing delta x is the VF equals VI plus AT. Okay, next, now you do what you did on the worksheet, solve for the unknowns. We want to rearrange that equation for acceleration, which you have done on the worksheet. You can look at it. I think you did this actual one. And turns out acceleration is VF minus VI divided by T. Okay, now we're ready to put numbers in. But before you put the numbers in, you have to check units. So you have to have, if you're doing an equation like this, you have to have velocity in meters per second. You have to have time in seconds in order to get your acceleration meters per second squared. So when we go back here, we see our time is in milliseconds. We have to convert. So we have to convert units. And so 600 milliseconds, remember milli is the same as 10 to the minus 3 seconds. Now you could punch that in your calculator, just type in 600 EE minus 3 equals, and it will convert it for you. This is equal to 0.6. Or you can do it by hand. Okay, so we're ready to put numbers in. So let's go ahead and calculate now. VF is 8.5 to the right. Put your units too, it's a good idea. You can see how it works. Minus -9 for initial velocity divided by 0.6 seconds. So you're actually adding those 2 numbers, 8.5 plus 9 over 0.6. And when you do that, you get 29.2 meters per second squared. So notice how these units work. You've got a meter per second divided by a second. The seconds don't cancel. A meter per second divided by a second is the same as multiplying by 1 over, because you invert and multiply when you have something on the denominator. And so that's how you get meters per second squared, which are the correct units for acceleration. Okay, the question also says how many G's. A G, 1 G, is 9.8 meters per second squared. So when you're just standing on the ground, you feel 1 G. if you are, suddenly violently accelerated, to get the number of G's you feel, you take your acceleration and just divide by 9.8. And this is how many G's this tackle would be. It's about 3. It's 2.98 or something. So it's about 3 G's. Now 3 G's is huge. That's a pretty violent kind of acceleration. If you were to sustain between 3 and 4 G's for more than about 3 seconds, you would black out. So that's a huge acceleration, 3 G's. Okay, now this also shows you that if you turn something around, it's a big force and it's a huge acceleration. So to turn around, to go from one direction to the other as a result of this impact, that results in a large acceleration, much larger than if you were to simply stop. So if you were just brought to rest, so say your VI was -9 and VF is 0, so this is just stopped, your acceleration in that case would be 0 minus -9 over the 0.6. And I don't know what that is. I have to do this quick calculation here. This works out to 15 meters per second squared. So that's a much smaller acceleration than the 29 by turning around. So this is turning around. Turning around. This is a huge acceleration. Stopping is a smaller acceleration. Okay, so every single kinematic question, you should follow those steps and it should all work out just fine.